Hi, my name is Graham Smith, and I'm one of the authors that helped develop the learning approach to mathematics that is found in our textbook as well as the video you are about to experience. To learn more about our approach to learning mathematics, visit the web address that accompanies this video. Now, enjoy the video. Perimeter and area. This video will help you find the circumference of a circle, find the area of a circle, and find the area and perimeter of a composite figure. Find the circumference of a circle. We'll start with some definitions. The radius is the distance from the center of a circle to its outer edge. And you can see right down here I have a picture of the radius drawn. We start at the center of the circle and go to the outer edge, and that distance is the radius of a circle. The diameter is the distance across the circle through its center. You can see here I have a picture of the diameter. It has to go through the center of the circle, and it goes all the way from one edge of the circle all the way across to the other. The perimeter of a circle is its circumference. And so here I'm going to draw a picture of the circumference. Now then, the circumference is the distance around the outside edge of the circle. So if we started at one point here on the circle and we went all the way around, that distance would be the circumference of the circle. So here I have a picture of a circle, and on the circle I have drawn the diameter, which is the distance across the center of the circle, going through the center of the circle, and also have the circumference, which is this green arrow going all the way around the circle. Comparing the circumference to the diameter, we see that the circumference is a little more than 3 times the diameter. So here is this green distance that went around the outside of the circle, the circumference, and here is the distance of the diameters. And if we add these diameters up, here we have 1 diameter, 2 diameters, and 3 diameters. And you can see that the circumference is just a little bit more than that. And so this 3 times, or a little bit more than 3 times as much, is actually pi. And so when we're calculating the circumference here, what we do is we take the circumference of the circle is equal to this 3.14, a little bit more than 3, which is pi, times the diameter of the circle. And that's how we get this formula for the circumference of the circle. Now, pi is a non-terminating, non-repeating decimal number, and this 3.14, actually those decimal numbers continue on forever. But for this class and for the particular problems we're looking at here, 3.14 is an okay approximation for us to use for pi. So we actually have 2 formulas that we can use for finding the circumference of a circle. The first one here is the one that we just got done talking about. The circumference equals pi times the diameter. Or we could use this second formula. The circumference equals 2 times pi times the radius. And these formulas are equivalent because remember, looking at the circle, the radius here was halfway across the circle. So that means it's half the diameter. So if I take this radius and multiply by 2, I actually get a number that is the same as the diameter over here in this formula. However, it is convenient to have both formulas because sometimes you'll have a circle where they give you the diameter, and sometimes you'll have the circle where they give you the radius. And again, for pi, we're just going to use 3.14. Now let's take a look at an example that will help you understand how to calculate the circumference of a circle. Example 1. Find the circumference. Use pi approximately equal to 3.14. Well, you can see in our circle here that we're given the radius. This 6 feet starts in the center and goes to the edge. So we're given the radius of the circle. So we want to use the formula then that involves the radius. And that formula is the circumference equals 2 times pi times the radius. Now we're just going to plug this information in. So the circumference then equals 2. Well, pi is 3.14. That's what we're going to be multiplying there. And then the radius of this circle is 6. So now we just need to multiply this stuff together. Now the order in which we multiply is not going to change the value. So what I'm going to do is I'm actually going to multiply these 2 whole numbers together first. 2 times 6, which is going to give me 12. So then I'll have 12 times 3.14. The advantage of doing that is then I don't have to multiply twice with a decimal number. Now I just have to do in the final calculation multiplying by a decimal number. So I'm going to come off on some scratch paper, and we'll take 3.14 and we're going to multiply that by 12. When we do that multiplication, we're going to get 37.68. And so over here, my circumference then is going to be 37.68. Now I want to make sure I put my units on there. It looks like the units here were feet. So this is going to be then 37.68 feet, because this is a measure of distance. So we need to have our units of measure on there. Now it's time to check your understanding of finding the circumference of a circle. Pause your video player and answer this guided practice question. When you're done, hit play to see how you did. Question 1. Find the circumference of the circle and use pi is approximately equal to 3.14. Well, let's take a look. Here in our picture, we're given now the diameter of the circle. And so since we're given the diameter, we want to use the circumference formula that involves diameter. And that is just this. Circumference equals pi times the diameter. Now we're just going to plug that information in. Well, we know that we're going to use 3.14 for pi, and the diameter of our circle is 6 feet. So we're going to multiply 3.14 times 6. We'll come over on some scratch work. And when we multiply 3.14 times 6, we get 18.84. And so the circumference of the circle is 18.84. And now we have to get our units of measure, which are feet. So 18.84 feet is the circumference of this circle. Find the area of a circle. We can use an experiment to get the formula for the area of a circle. If we cut a circle into 8 pie-shaped sectors, and so here we have a circle, and we've cut it into 8 pie-shaped sectors. We're going to place the pie-shaped sectors together to make a figure that looks almost like a parallelogram. So if we take these pie-shaped sectors and alternate them like we've done here, we get a figure that is very close to a parallelogram. And we already know how to find the area of a parallelogram. So right down here in our formula we have that the area of a parallelogram is the base times the height. Now let's take a look at a couple of these things, the base and the height, in our figure up here. Well, the height of the parallelogram is actually just the radius of the circle, or pretty much close to the radius of the circle. You can see here each one of these pie-shaped sectors has a distance that's equal to the radius. So the height of our parallelogram then is almost the radius of the circle. And now if we take a look at the base of the parallelogram, if we look at, in this particular case, just the green pie-shaped sectors, right? And if we went halfway around the circle, right, that would give us the outside edge of all of these green-shaped sectors. And so that's half the circumference. And so you can see here we've written the base is approximately equal to the circumference divided by 2 to get half of that. Now if we plug this information into the formula down here for base and height, we're going to actually get the formula for the area of a circle. So let's see. The base was the circumference divided by 2. Well, remember that the circumference over here is 2 pi r. So what we have for the base is we have this. We have 2 pi r, and we want to divide that by 2 because that was half the circumference. And now the height was just the radius of the circle, and so we're going to leave that at r. And so taking a look here, if we're simplifying this now, look, we have this common factor of 2. I'll rewrite the formula here. Now we're going to simplify this. We have this common factor of 2 that we can divide out. So we can divide a 2 out there, we can divide a 2 out there, and that leaves us with just pi r and then times r. Well, r times r, the simplest way of writing r times r is just r to the second power. And so we're going to come over here in our formula and say pi r to the second power, or sometimes we say that's pi r squared, and there is the formula for the area of a circle. The area of a circle is pi times the radius squared. And so now here is our official formula for finding the area of a circle. The area of a circle is just like we discovered before, is pi times the radius squared. And here we're going to use pi equal to 3.14, and again just a reminder that r is equal to the radius of the circle. So we're going to need the radius of the circle to find the area of a circle. The diameter won't work. We don't have a formula that involves the diameter here. So you'd have to take the diameter and use that information to find the radius first before we'll be able to find the area of a circle. Now let's take a look at an example that will help you understand how to find the area of a circle. Example 2. Find the area. Use pi approximately equal to 3.14. Okay, so we're going to start with our formula for area. And again, the area of a circle is pi times the radius squared. Now we're just going to plug this information in. Notice in the circle here, the 10 feet was the radius. So that's good because that's the information that I need in this formula. So I'm just going to plug that 10 in for the radius. And so let's see, then the area of this circle is going to be pi, which is 3.14, and then times the radius squared, which is 10. So we have times 10 and then to the second power. Now we want to follow the order of operations when evaluating this expression on the right. So I want to start with the exponent 10 to the second power. So let's see. We're just going to rewrite pi in there, 3.14. 10 to the second power, well that means 10 times 10. And that's going to give us 100. So I'm going to have 3.14 times 100. And now I just need to multiply 3.14 times 100. So we'd come over on some scratch work, 3.14 times 100. Well, multiplying by 100, all that's going to do is move that decimal place 2 places to the right. It's going to make this 3.14 bigger by moving those decimals 2 places to the right. So we're actually going to get 314, and the decimal point would be right there then. But we'll just write that as 314. So the area of this particular circle then is 314, and now we want to indicate that this was a measure of area. Notice we were using feet, so we want to say that our answer then is feet squared, or we would want to write square feet. So the area of this particular circle is 314 square feet. Now it's time to check your understanding for finding the area of a circle. Pause your video player and answer this guided practice question. When you're done, hit play to see how you did. Question 2. Find the area. Use pi equal to 3.14. Let's take a look at our circle here. They're telling us this is 8 feet, but this is actually the diameter of the circle. And our formula, our area formula for a circle is this. Area equals pi times radius squared. So we need to get the radius in order to use this formula. So if the diameter is 8 feet, the distance all the way across the circle is 8 feet. Halfway across the circle then is going to have to be 4 feet. So the radius of this circle is 4 feet, and that's the information we're going to want to plug into our formula here. So let's see. Area equals, for pi we have 3.14, and we're going to multiply that times the radius, which is 4, to the second power. And so now again we want to follow the order of operations, so we want to do this exponent first. And so 4 to the second power means 4 times 4, which is 16. So I'll rewrite my formula here, 3.14 times 16. And so now I need to take 3.14 and multiply that times 16. And when we do that calculation, we come up with 50.24. So then the area of this circle is 50.24, and we want to make sure that we indicate this is a measure of area. We were using feet originally, so we want to have our answer then in square feet. Find the area and perimeter of a composite figure. Composite figures are made up of 2 or more simpler figures. To find the area of a composite figure, find the area of each simpler figure and then add or subtract the areas. To find the perimeter of a composite figure, add the lengths of all of the outside edges. Now let's take a look at an example that will help you understand how to find the perimeter of a composite figure. Example 3. Find the perimeter of the composite figure. Use pi approximately equal to 3.14. Let's take a look now. The figure that we have here is a basketball key, and we want to find the perimeter around this basketball key. So in order to do that, we kind of need to see what that perimeter looks like in terms of the shapes that we're familiar with. And if you take a look here, I've kind of drawn this out for you. So the back side of the basketball key is kind of made up of part of a rectangle, and then the front side of the basketball key is made up of half a circle. So to find the perimeter, we just need to find the perimeter of each of these 2 things and then add them together. Well, let's start with the back part that's almost a rectangle. We know this is 15. We know this side over here is 10 feet, and then we know the top is 15 feet. So to find the perimeter of that part of the figure, all we need to do is add those together. So I would say, to find the perimeter of this part, we're going to say 15 plus 10 plus 15. And let's take a look at what that perimeter is going to be then. So 15 plus 10 is 25. And then if I take 25 plus 15, let's come over on some scratch work. 25 plus 15. 5 plus 5 is 10. Carry the 1. 1 plus 2 is 3. Plus 1 more is 4. So we get 40 feet around that part of the basketball key. Now we need to find the perimeter of half of this circle, which means we're going to need to find the circumference of this circle and then cut it in half or divide it by 2. Well, in order to find the circumference of the circle, I'm either going to need to find the radius or the diameter. Let's take a look at our original picture to find one of these measures. If we see here that this side is 10 feet, that means coming across this rectangle, this side over here is also going to have to be 10 feet. And that happens to be the diameter of our circle. Once we have the diameter of our circle, we can now find the circumference of this entire circle. So we would say the circumference of this circle is going to be equal to pi times diameter. But in this case, we want to divide it by 2 because we only have half a circle. So let's see. Now we're going to plug in our information. Pi was 3.14. And we are going to multiply that times the diameter, which was 10. And then we're going to end up dividing that by 2. Multiplying 3.14 times 10, all that's going to do is move the decimal one place to the right to make 3.14 bigger. So it will become 31.4. And then we have that divided by 2. And so now we need to go ahead on some scratch work here and do some long division. So we would say 2 is going into 31.4. When we do that division, we're going to get 15.7. And so the circumference of half of this circle is going to be 15.7. And we are working in feet, so that's 15.7 feet. Now, we weren't asked to find the circumference or perimeter of each of these objects separately. We were asked to find the perimeter of the whole thing together. So now what we need to do is we need to add these two perimeters together to find the perimeter of this entire figure. So we would say then the perimeter in total then is going to be 40 plus 15.7. And when we add 40 plus 15.7, let's see, 15.7, and we're going to add 40 to that. There's the decimal in 40. So we're going to get 755. So we're going to get 55.7, and we were working in feet, so we'd say 55.7 feet for the perimeter of this composite figure. Now it's time to check your understanding of finding the perimeter of a composite figure. Pause your video player and answer this guided practice question. When you're done, hit play to see how you did. Question 3. Find the perimeter of the composite figure and use pi equal to 3.14. Well, let's take a look here at our composite figure. The perimeter around this is going to be first the perimeter around this part of a rectangle here. And then we also, on the inside there, we need to find the perimeter of half a circle. So this is very similar to the last one we looked at. So the perimeter of this rectangle is going to be 15, 10, and 15. So the perimeter is going to be 15 plus 10 plus 15. So 15 plus 10 is 25. And then we need to add 25 and 15 together. So we come on some scratch work here and add that up. 5 and 5 is 10, carry the 1. 1 plus 2 is 3, plus 1 more is 4. So the perimeter of the rectangular part of that is 40 feet. Now let's take a look at this half circle. Well, in order to find the circumference of a circle, we're going to need to know the radius, or the diameter. And if you take a look, if this side of the rectangle here was 10 feet, if we kind of draw an imaginary line here, this side of the rectangle also has to be 10 feet, and that is the diameter of our circle. So we can say now the circumference of the circle, well, we don't want the whole thing, we want half of it, so we would divide by 2. We're going to take pi times the diameter, which in this case is 10. So let's see, plug in pi there, we have 3.14 times 10 divided by 2. So we'd say 3.14 times 10 is 31.4 divided by 2. And so we're going to do some long division here. So over on some scratch work, we're going to go 2 into 31.4. And when we do that division, we're going to get 15.7. So half the circumference here is going to be 15.7. And that was feet. And now we were asked to find the total perimeter here, so we need to add these things together. So the total perimeter is going to be 40 plus 15.7. And so if we add 40 and 15.7 together, start with some scratch work here. See, 40, there's a decimal in 40, and then we have 15.7, so we'd add a 0 there. So we get 7 point and then 5. So we're going to get the perimeter then is 55.7, and that was feet. Now let's take a look at an example that will help you understand how to find the area of a composite figure. Example 4. Find the area of the composite figure. Use pi equal to 3.14. Let's take a look at our composite figure here. Again, it's a basketball key. To find the area of the entire basketball key, we're going to need to find the area of the rectangle and also the half circle that goes on the top of the key. Let's start with finding the area of that rectangle. To find the area of a rectangle, our formula tells us we need to know the length and the width. And we have both of those pieces of information on our picture here. The length of our rectangle is 15 feet. The width is 10 feet. So we're just going to plug this information in. The length was 15 feet. The width was 10 feet. We multiply those two together. We get the area of the rectangle is 150 square feet. Now let's take a look at finding the area of half of the circle. Well, remember, to find the area of an entire circle, we need pi times radius squared. Well, we're only going to want half of that. So the area of this figure is going to be pi times radius squared, and then we're going to want to take that answer and then divide it by 2 in our last step to get half the area of that circle. Now let's see, we need to find some information here. We're going to need to know pi, but we already know that. And we're also going to need to know the radius. And now we don't know what that radius is. So let's go back up to our picture and take a look and see if we can figure out what that radius is. Well, in our rectangle, if this side over here is 10 feet, the side opposite that in a rectangle also has to be 10 feet, which means that side of the rectangle is 10 feet. Well, that's also the diameter of that circle. So if the diameter of this circle, and we'll use d for diameter, if the diameter of that circle is 10 feet, the radius is going to be half of that. So we know the radius of this circle is 5 feet. Now we're ready to plug that information into our formula. So let's see, area, we have 3.14 for pi times our radius of our circle was 5. So we have now 5 squared, and we're going to divide that by 2. Okay, let's come over here to finish this up. So the area is, let's start, we would follow the order of operations. Calculate our exponent first, which is 5 to the second power, which means 5 times 5. And 5 times 5 is 25. So we're going to get 3.14 times 25 divided by 2. Now what we want to do is multiply 3.14 times 25. So we would go on some scratch work here, 3.14 times 25. When we did that multiplication, we get 78.5. And so we have 78.5 divided by 2. So we're going to need to do some long division. And so we would do 2 going into 78.5. When we do that long division, we get 39.25. And so the area of this half circle is 39.25. We're dealing with feet, so that's going to be square feet. Now, to find the area of this entire composite figure, we are going to need to add the areas of the rectangle that we found with the half circle that we found. So we're going to add those two together to get the total area. So the total area of this figure is going to be 150 plus 39.25. And let's find some scratch work here. We'll come all the way over here. We're going to say 150. There's the decimal point. 39.25. 39.25. adding this up. Put some zeros up there, bring down our decimal. 0 plus 5 is 5, 0 plus 2 is 2, 0 plus 9 is 9, 5 plus 3 is 8, and then we bring down the 1. So our total area here is 189.25, and that was square feet. Now it's time to check your understanding for finding the area of a composite figure. Pause your video player and answer this guided practice question. When you're done, hit play to see how you did. Question 3. Find the area of the composite figure. Use pi equal to 3.14. Well, let's take a look at our figure here. We kind of have a weird part of a basketball key where some of it's missing, or part of this rectangle is missing. And to do that, to find the area, what we're going to need to do is we're going to need to find the area of the entire rectangle, and then we're going to want to subtract from that half circle. Well, let's start by finding the area of that rectangle. Again, to find the area of a rectangle, we just use length times width. In this case, our length is 15 feet, our width is 10 feet. So the area is going to be 15 times 10, which is going to give us 150 square feet. Now we need to find the area of that half circle so that we'll be able to subtract it. Well, to find the area of a circle, we are going to need pi times radius squared. Now we don't need that entire circle, we only need half of that, so we're going to divide that by 2 to find the area of this figure. So it looks like we're going to need to find the radius of the circle. Let's go back up to our picture and figure this out. So if this side of the rectangle was 10 feet, then this side of the rectangle also has to be 10 feet. And that is the diameter of that circle. So that this 10 feet is going to be the diameter of the circle. So to find the radius of the circle, the radius of that circle is going to be 5 feet. So let's plug this information in. So I have 3.14 times 5 squared, and we're going to divide that by 2 so we get half the circle. So following the order of operations, we would start with our exponent. So we're going to get 3.14. 5 to the second power means 5 times 5, so that would give us 25 divided by 2. Let's take a look here. So we're going to have 3.14 times 25. So we're going to do a little scratch work. We do 3.14 times 25. When we did that multiplication, we get 78.5. So rewriting our formula again, we have the area is 78.5 divided by 2. So we're going to need to take that 78.5 and divide by 2. So off on some scratch work, we would go 2 into 78.5. When we do that division, we get 39.25. So it looks like the area of that half circle is 39.25, and that was square feet. So now to find the area of our composite figure, we are going to have to take the area of the entire rectangle and subtract from that the area of half of that circle. So our total area here is going to be 150 minus 39.25. And so we're going to have to do some scratch work here again. So let's see, we'll come over here to the left. So I got 150. Put some decimals in there, and we're going to be subtracting from that 39.25. Well, we're going to need to borrow all the way over at the 5. So we borrow from the 5, which would make it a 4. Then this will make this next one a 10, but we're going to need to borrow from that 10. So that'll make it a 9. Again, we're going to need to borrow from this one afterwards, so that'll be a 9. So we end up with 10 there on the end. 10 minus 5 is 5. 9 minus 2 is 7. Bring down the decimal point. 9 minus 9 is 0. 4 minus 3 is 1 and 1. So it looks like then our total area is going to be 110.75, and that is square feet. If you found this video helpful, I encourage you to check out our other videos that we have on YouTube, or visit the web address that accompanies this video to learn more about our approach to learning mathematics.